and it's a pleasure to introduce Oleksii Ivanchenko, a solution architect from Amazon. Oleksii will share firsthand experience on how to use the AWS IoT for storing, analyzing, and visualizing data. He will delve into the AWS IoT capabilities for managing and monitoring IoT devices, as well as what AWS IoT is able to provide in terms of device software. Oleksii, welcome on stage. Welcome to the Yalantis IoT Landscape live event. The stage is all yours, please.
Thank you, Victor. Hello, everyone. Thank you, Dennis. Thank you, Dennis, for really great speech and presentations. Was pleasure to hear it. And let me introduce myself. My name is Oleksii Ivanchenko. I'm working for AWS for a little bit more than a year, working from Czech Republic for Ukrainian customers. And today we are going to talk a little bit about the services that we are having in AWS to help you with your IoT workloads. Let me share my screen and we can start. By the way, on the meeting, we also have my colleague Jan Schwab. He is currently in the listen only mode and reading mode in the chat. So if you would like to ask whatever questions you have regarding AWS or IoT, feel free to post them into the chat. He will try to respond as soon as possible. So let's start. Basically, as all of you may notice that IoT market continue to grow at an aggressive pace. What this means for a company or team managing an IoT devices or connected products platform is that they can expect to build and launch more and more connected devices. And at this speed, they need to have ability to effectively manage all the connected devices in their fleet at high scale. And when we are checking the variety of our customers, we can see that our customers like Fender is using IoT for optimizing manufacturing. Philips is using IoT devices for remotely monitoring patient health care and tracking inventory level in their warehouses. Such companies like iDevices or iTron using it for connecting homes, buildings, cities, and Bayer are using it for growing crops. And more use cases all around the like high variety, a big variety of our customers, including transportation, including safety, including the managing of energy consumption and resources, agriculture, whatever. Basically, every field what you can imagine right now. And in essence, you need three different types of services and software when we are talking about the IoT in the cloud and on the edge. It's IoT device software to build devices that operates on the edge and work with the clouds. It's IoT connectivity and control services to connect, manage, and secure your devices at the scale from the cloud. And IoT analytics services that make sense of IoT data, take actions to solve business problems. And it's not like layered architecture, or we should not consider it as the layered architecture. It can be used independently, it can be used in connection, can be used in variety of ways. And we are trying to cover all the this kind of topics, this kind of the requirements with our services, with variety of our services. Um, Across myriad of the customers that we are helping to connect their devices to the cloud, we constantly see set of common challenges connected to the product space. We see top four patterns when we are talking to our customers. First one is extracting value from IoT. For customers new to IoT and haven't connected their product to the cloud, it can be challenging to find the business model that supports the additional development effort and operation costs on IoT solution. However, leveraging the cloud is actually bringing them new ideas and new ways how to get additional stream revenue streams, um, open new potential products with new innovation and series. Another challenge is managing and scaling large fleet of the devices, which is always a big concern for the customers who are expecting to increase their fleet to like huge, really huge sizes. They can start with tens or hundred of the devices and eventually scale to millions or uh, tens of millions of the devices. Managing a fleet can be really challenging, and AWS is helping with their services. Also, we are seeing the customers that are um, struggling with managing devices itself, with deploying and delivering new software, new functionality to their devices securely in the control cycle with the best practices on it, which are also can be solved by the services that are provided by AWS. And security is always a job zero for the AWS, and using our technologies like Greengrass, IoT Core, helping our customers to keep devices, data, and customer information secured and protected. So when the customers are coming with the question, how can I connect my data securely and handle the data that are generated at scale? We are coming to our connectivity and control services. And one of our main services in this section is AWS IoT Core. Um, IoT Core is the serverless platform that consists of um, multiple components that are supporting you in your journey in your daily life with your IoT devices. It consists of the identity service providing the authorization and authentication mechanism for your devices using the certificates, using secret password, using different other custom methods for the authorizing your devices. This is device gateway to securely connect your devices to AWS cloud and other devices. It consists of the message broker for processing and routing data to the cloud. Rules agent is one of the uh, hearts of our um, IoT core capabilities, which can recognize and trigger our big variety of services in AWS based on the events that are coming from your devices, from your edge computing devices, from gateways, finding the patterns and do some additional computation and trigger such devices, such services like Lambda function, Kinesis, like step functions, huge variety of different services in the AWS. Also, device shadow is very interesting capability that allowing you to control and manipulate your devices even when your devices is out of temporary out of the internet connectivity. So it's basically making the shadow of your device which are holding the last state of device which were connected to the network, which were connected to our infrastructure, and holding the state, and then you can manipulate with this state while the device is disconnected. And as soon as device will be connected to the internet, connected to our services, AWS IoT Core with the device manager will synchronize all the state. Will it have the mechanism for solving the conflicts if there was any kind of the mm, different commands that are coming from different sides, and help you to manipulate your devices even if the connection is not persistent. Also, there is the registry where you can enrich your devices with additional metadata, search it across millions of the devices, or use device locator to find and group your devices based on the location of your devices. As part of the IoT core, there is the IoT Core SDK, which allowing you to do the um, high variety of different adjustment of your devices and connecting them to the cloud to do different procedures. It's abstracting MQTT protocol to have more user friendly and easier way to manage your topic, shadows, job, and so on. It support mobile and device SDK. It has the mobile and device SDK, and mobile SDK support platforms like I, iOS or Android. It support different common languages like JavaScript, Python, Java, C, C++, and as I have checked right during the talk of Dennis, there is also the Rust support in the preview right now, so you can expect that it will be available sometime in the future. It have core capabilities to build your own logic inside of your devices, and of course it's going with end-to-end security utilizing TLS 1.2 or later. And after that, we have all our data are streamed, and or our devices are connected to cloud and gather the data. We need to do something with the data. And for these cases, service like IoT Wise coming to help. IoT SiteWise is managed service that enable industrial enterprises to collect, store, organize, and visualize thousands of sensors data stream across multiple industrial facilities. It can be installed on the edge, it can be used in the cloud. You can uh, ingest data ingest data from different sources using the MQTT, using the OPC UA, and different protocols. It can be ingested The data can be ingested directly from the SDK, and the data can be not only ingested but as well enriched during the ingestion and storage. You can create the models. You can create the models based on the data that are coming to your storage, and as well you can do hierarchical models to organize and um, manage your data in the way you would like to. Um, Using the SiteWise, you can also store the data in time series manner to do the real-time analytics on it using the warm storage, which will provide you the high performance and very nice capabilities of things that you used to have in different time series databases to aggregate data, to do the analysis on the data, to have low latency on analyzing data in real time or close to real time. Or you can use data in the cold storage for optimizing your cost and do analytics on the big variety of the or big range of the data to see the big picture of your of your devices and how they worked and what they have capable of. Another very important stuff is doing any kind of the transformation with your data or doing computation of on your data right in the store or before the just ingestion of your data, plus putting additional hooks, alarms, or events on your data so you would have such standard metrics that allowing you to understand when your sensors or when your facilities are requiring the repairment, what is the cycle of the failure, and so on and so on. And last but not I mean not last, but there is a lot of capabilities, but last which I would like to talk about is data visualization. As I said at the beginning, data visualization can be done on the on the cloud in the special website, which will be deployed for you again in the serverless manner, or it can be created as the dashboard right on the plant floor, where all the operation happening. It will be used through the secure method of the authorization and can work even when there is no connection to the internet. So bringing your analytical capabilities right to the floor, closer to the um, places where your sensors are installed and operates. And last but not least is um, device software, very important topic, which are interesting, which are like used by our customers. We have variety of capabilities for running the device, running our software on the devices. If it is very small devices like small controllers, you can use the free RTOS system, which will do the minimum work, like just sending data about current state of your sensors, like vibrations or whatever, do the underlying implementation of the security and update of this system through the IoT Core or um, different another capability like Greengrass. Or if you have the gateway which is installed uh, on your facility or somewhere in the location when there is no internet, but you still need to process, analyze, and, for example, aggregate or run ML workloads like um, whatever training or using the um, like inferentia of your models. For this, we have the IoT Greengrass, the solution which can be deployed on whatever device that can basically run Linux. So, but before that, we were talking to our clients and we realized that usually um, there are multiple ways how you can work with your solution, how you can deliver or mm, create your solution. And there is like option one, like buy hardware, build your application, and build supporting layers of your stack from the scratch. You can also buy hardware, build your application, and buy some IoT supporting layers, and then integrate all this stuff and test these pieces and make sure that it's all working together. And the last one is, or not the last one, but another one is to buy the hardware, build your application, and use Greengrass to take care of your IoT supporting layer. With like all of these are all of these three approaches have their benefits and problems in the end, but in like what we found from our statistics and our customers, that using IoT Greengrass bring them such capabilities as low time to market, less maintenance, and easier operations in the end. IoT Greengrass can work. Basically, IoT Greengrass is an open source edge runtime and cloud service that helps you build, deploy, and manage your software. Customers can use Greengrass on the devices that are constantly connected to the internet, like, for example, some appliances like TV or media servers or whatever, which are like working in the facilities which have dedicated internet connection for this device and constantly running. Or Greengrass can be deployed to the hub, to your gateway, and then manage and collect the data from variety of smaller IoT devices on your factory facility, mm, whatever, you name it. And then time to time, when the internet is connected, it can offload the data into the cloud, or it can do the computation. It can do inference on the on device itself. It pretty useful. Usual use case is to do the aggregation of all the data that are coming from the smaller device into the hub, do the shrinking, do the remapping of the data, and then decreasing the amount of data that need to be streamed into the cloud for like more efficient processing. And taking talking about these two variants of the managing the devices and deploying the devices, we can find these capabilities of Greengrass. Is first managing the software on our IoT devices, updating the runtimes, updating the packages, integrating it with the um, core cloud services like mm, Lambda function or DynamoDB through the SDK that can be installed, or just stream the data into the IoT core. It can control device fleet, like gathering the data, sending the command turn on, turn off, and so on, or be used as the data broker. Or, as I said, you can use it for powering your sorry ML workloads on the edge. And when we are talking about the benefits which can be calculated from the using of the or counted, which can be used um, from using of the ready solution like IoT Greengrass, is saving your time to market. So based on our observation, it can save you from 6 to 9 months comparing to building your own solution with similar capabilities, or save you uh, like up to 1.5 million for the development cost. It's really depends on the country where you're building it, how you're using it, and so on. But you can imagine basically the numbers, or lower your maintenance costs or operation costs. In the nutshell, um, what is like Greengrass? Uh, it's basically the open source software that can be installed on Linux, Windows, and other systems, which are consist of core component, what we call nucleus, and then you can install additional components like CLI, local Lambda functions, Docker containers, or bring your own runtimes there to run your local workloads, run your local edge computations, do the different type of the streaming or inference and so on. So it can work without or with the internet, and you can bring your models. You can update it remotely from the cloud, single device or millions of IoT Greengrass devices. And then in the end, you're paying just, I'm sorry, um, in the end, you're paying just for the IoT Greengrass devices that are uh, connected, was active in the at least once in the month to the cloud. So if your devices which have installed IoT Greengrass and running somewhere in the sea for 6 months is without any internet connection, and then just once per 6 months is offloading the data into our data center, you don't pay any extra cost for it, basically, just for 1 month. And yeah, as I said, there are edge capabilities like local messaging, data storing and synchronizing the state, inference of the ML workloads, streaming the data, storing the secret for your local devices, or update, stop device like small IoT devices, restart devices, send the logs, do the automatic recovery, and so, or use the um, such things like over the air updates, use local tools, uh, help with the remote app management, like for using your mobile phones, or remote manage the whole fleet of your devices on the factory. uh, I'm almost out of the time. I think that's all what I wanted to tell you about the fleet of our services. This is just a small part which can be covered through this period of time. But if you will have any kind of the additional questions, or you need our support, feel free to write me. I will do my best to uh, to to support you in your journey with AWS IoT services. Thank you for your attention.
Thank you, Alexei. It was really insightful, and it was something like a guide into the IoT technologies hosted by AWS with so many opportunities. It was really nice. Thank you so much.